Hi, everyone. Welcome to Lecture 5. We're going to be talking about economies of scale and trade today. So in the two models of trade we've studied so far, the Ricardian model and the Heckscher-Ohlin model, we've had a common motivation for trade. Countries trade because they are different. And the story there is that we have differences in domestic opportunity costs, which we call comparative advantage. And this leads to benefits from specialization in trade. Today, we're going to see when there are economies of scale, countries can gain from trade even when they are identical. And the reason is that with increasing returns to scale, specialization itself can be a source of comparative advantage. So what exactly are returns to scale? Well, we define this based on what happens to total output when we double total inputs. So if when we double inputs, we exactly double output, then we would say that a production function has constant returns to scale. And this was the case we looked at in the Ricardian and the Heckscher-Ohlin models. If when we double inputs, we less than double output, we have what's called decreasing returns to scale. And if doubling inputs more than doubles output, we have increasing returns to scale, which is also called economies of scale. So we can also rephrase this in terms of marginal cost. So with economies of scale, marginal cost falls as production increases. The flip side of that would be reframing this in terms of marginal productivity. So if marginal cost is falling as production increases, then marginal productivity is rising as production increases. So let's look at an example using the Cobb-Douglas production function. So remember, with Cobb-Douglas, the sum of the exponents tells us the returns to scale. So if the total exponents sum to 1, then we know that we have constant returns to scale. That's going to be the case here. See the 0.4 and 0.6 sum to exactly 1. If the sum of the exponents is less than 1, we have decreasing returns to scale. And if the sum of the exponents is greater than 1, we have increasing returns to scale. So let's compare some different scenarios across these three different production functions with different returns to scale. So if we're using exactly 1 unit of labor and 1 unit of capital, then for these three different production functions, we're going to have the exact same quantity. We'll get 1 output. So what happens when we double our inputs? If we go from 1 unit of labor and capital to 2 units. Constant returns to scale, we double our inputs, we will exactly double our outputs. We go from 1 to 2. With decreasing returns to scale, we will less than double our outputs. So we'll go from 1 to 1.86. And with increasing returns to scale, the gain is going to be more than twice of our output. We're going to go from 1 to 2.14. And as we continue to increase quantities of our inputs, so we go from 2 units of labor and capital to 3 to 4, the differences between these production functions are going to compound. That's because with constant returns to scale, marginal cost is not changing. An extra unit of labor and capital will always get us 1 extra quantity, but with decreasing returns to scale, as we add more and more inputs, we're getting less and less out of them. With increasing returns to scale, our marginal cost is falling and our marginal productivity is rising. And so you can see that when we go from, when we went from 1 to 2, we got an extra 1.14 units of quantity. And when we go from 2 to 3, we get something that's a little bit more than that, and then a little bit more than that as we go from 3 to 4. So the differences between these are going to compound as we increase inputs. So when we have economies of scale, we're going to have what's called a forward falling supply curve. So as we increase quantity produced, marginal cost is going to fall. And as marginal cost continues to fall, average cost is also going to decline. So average cost is simply total cost divided by total quantity, or in other words, it's the average marginal cost. So marginal costs are going to be high at lower output levels and low at greater output levels. And so the average cost curve is also going to be falling. In the market equilibrium, the average cost curve is going to be the supply curve. And so larger markets are going to be further out on the average cost curve and will have lower supply. Interestingly, this means that shifts out in the demand curve, so positive demand shock, can actually reduce the price. So this puts us in a very different world than the standard supply and demand framework. So what exactly are the sources of returns to scale? Well, there's a typography of two different types of economies of scale, internal and external. With internal economies of scale, scale is defined by production levels at individual firms. So the classic example of this would be fixed costs. So for example, to build the first Ford F-150, you need to have a design of the car. You need the factory. You need the machines. You need the entire workforce, not just the production staff, but the accountants and the managers and all the rest of it. And lastly, after all that, you need the actual parts of the F-150. To build the second one, you just need the parts. You've already got everything else. So the cost of building the first Ford F-150 was astronomically high, but the cost of building the second is much, much smaller. There are other sources of internal economies of scale. So for example, learning by doing. As firms produce more and more cumulatively, they gain experience, they learn how to do things better, and there are efficiency gains from that. And lastly, there can be internal specialization in trade. So this is like applying trade theory that we've been, thinking about the gains from trade within, across countries, but to firms. So as firms get larger, they can have their workers in different departments specialize in doing different things, and there can be gains, efficiency gains to that. So the alternative to internal economies of scale is external economies of scale. And here, we're defining scale by production at the market level or the industry level. So it doesn't matter how big each individual firm is, it's total production at the market that determines the economies of scale. So there are a few sources of this. A big one is labor market pooling. So for example, in Silicon Valley, there's a large market of computer scientists, software engineers, and various people with specialized manufacturing experience. And all of that means that if you're going to start a firm in the high tech or semiconductor or software industry, you really want to be in the Bay Area or Silicon Valley because that's where the labor is going to be. It's going to make your hiring costs lower. You can also have specialized suppliers of different types of inputs. So there can be specialized parts, there can be specialized labor like contractors. There can be things like shipping. Certain industries have very different shipping requirements and practices, and so you might need to deal with shipping staff or companies that have industry-specific experience, and that's going to be easier if there's a lot of other people doing the same thing. And there's all sorts of other things like lawyers. For example, in the West, the legal framework around water rights is very different than in the East. And there can be a specific market for types of lawyers that understand that. And there's all sorts of things. Industries can require specific human capital or inputs, and it can be easier to get those. You can get those at a lower cost if there's other people doing the same thing. And lastly, one of the classic examples of this was what's called shared knowledge. So if there's a lot of people working in the same industry, in the same place, there can be something in the air in that place where knowledge is just shared openly in coffee shops or in the streets or through social networks. And so it can be easier for best practices or new research and development to disseminate, and that can lead to productivity gains. So another word for external economies of scale is also agglomeration economies. And the idea is that when you have a lot of resources, productive resources agglomerated in one place, like cities or manufacturing hubs, that's going to lead to economies of scale. So in this lecture, we're going to be just looking at external returns to scale. And the reason is that once we have returns to scale, we have to be very careful about setting prices and dealing with competition. So with internal returns to scale, we actually have to depart from assuming perfect competition. So remember, perfect competition is simply that price equals marginal cost. Well, if marginal cost is continually declining, and if we have internal returns to scale, that simply won't work. Why? Because um, the marginal cost of the last good is going to be less than the marginal cost of all the previous goods, which means that it's lower than the average cost. So with internal economies of scale, marginal cost is always lower than average cost. And if we're pricing at marginal cost, that implies that profits are going to be negative. And that's not a sustainable equilibrium. With external economies of scale, we could have an environment where each firm has constant returns to scale in production, but productivity depends on the total size of the industry. So for example, we have this firm level production function where lowercase q is firm level production. That's going to be equal to just a linear function of total labor input. So A is marginal productivity of labor, L is labor that this firm is using, and we can see that A depends on the total quantity produced in the industry, which is capital Q. And it depends on that in this specific form. So there's a certain base level of productivity B, and as total quantity increases, A is also going to increase. Importantly here, each firm takes A of Q as given. So from their perspective, they have linear production. So they have constant returns to scale. It doesn't matter how much they produce, it's how much everyone else is producing for the various reasons we talked about before. Labor market pooling, specialized suppliers, or just shared knowledge. So we're going to look through a quick example here, and we're going to do this in a largely non-numerical sense. So for this example, we're going to have two identical countries, home and away. They're only going to produce using labor, and there's two sectors, jets and computers. Both have external economies of scale, and production is going to have this same type of linear firm level production, but economies of scale at the market level in both sectors. So first, let's look at the PPF when we have economies of scale. So as total production in each sector rises, marginal labor productivity in that sector rises. That means as we produce more of something, the marginal cost of it is going to fall. So this gives us a PPF that has a convex shape. So for example, as the production of jets rises, the opportunity cost of producing jets falls. We become better at producing jets and worse at producing computers. So this means that the PPF becomes flatter. So if we produce more jets, the opportunity cost of jets falls. And in the autarky equilibrium, this means that the price of a good is going to be lower if the country produces more of it. So if we're out here on the PPF, then we're going to be a low-cost producer of jets. If we're over here, then we're going to be a low-cost producer of computers. So rather than in the Heckscher-Ohlin environment, where specialization was costly, here, it's quite the opposite. Specialization is beneficial. We have more resources overall if we're specializing. And if we want to consume both computers and jets somewhere in the middle, we have to give up a number of total resources. So what happens when we trade with two economies that have this same identical PPF? If we were in a Ricardian or a Heckscher-Ohlin model, there would be no gains from trade. However, let's see what happens with economies of scale. So suppose that we have these two economies and they aren't trading, and home is specializing in jets and away is specializing in computers. And actually, sorry, these two don't match up. Home is actually specializing in computers over here, and away is specializing in jets. So let's just assume that the global relative price of jets is just something between the opportunity cost of jets in the two countries. So home is specialized in computers. The opportunity cost of jets is going to be the slope of the PPF here. And for away, they're producing all jets. The opportunity cost is going to be the slope of the PPF here. And the global equilibrium price is just going to be something in between. So it's going to be a straight line, and it's going to have a slope that's greater than the production possibility frontier in home. So if home takes their computers and they trade them from jets, they get to move along this line that goes out past their PPF. So by specializing in computers and trading for jets, home can actually consume more um, jets and computers than if they were in autarky, because the CPF here is outside of their PPF. And the gains from trade are largest here in the middle, where they're consuming relatively equal quantities of both computers and jets. So if they like to have both, they're going to be better off from trade. And in a way, they are specializing in jets, but if they trade for computers, they get to move along this line, has a slope greater than the slope of their PPF, and you can see that they also have a gain from trade. And again, the gain from trade is largest if they're consuming similar quantities of jets and computers. So in this middle here. So despite having two identical countries, there are gains from trade. And this is because specialization itself can be a source of comparative advantage. However, we just kind of assumed who was going to specialize in what. We just assumed with, a random price. And we did that because with economies of scale, pinning down the exact trade equilibrium can actually be quite difficult. It's not as easy as it was before. So let's think about the pattern of trade for a little bit. What happens when we open an economy to trade? Well, countries will specialize in and export goods that they are low cost producers of. So you want to be selling stuff that you can produce cheaply and sell for a greater price. In the Ricardian model, there was always just one autarky price. So it was easy to see who was a low cost producer of what. In the Heckscher-Ohlin model, uh, prices still depended on what you were producing, but we had an assumption of the same demand in each economy, which meant that we could always figure out who was going to be the low cost producer. With economies of scale, it's not so easy. And that's because specialization can be self-reinforcing with economies of scale. So if you're already producing jets, then it's very likely that you're going to be the low cost producer of jets. And you're further incentivized to specialize in jets, which cements you as the low cost producer of jets because it further lowers your opportunity cost of producing jets. And so what this means is that initial production plays a very major role in the direction of specialization. If home was already producing a little bit more jets, then they're going to fully specialize in jets once they start. Here, we sort of assumed that they specialize in computers, so it must have been the case that they were initially producing just a little bit more computers than Away was. And that kicked them off on this process of growing their industry further, getting more economies of scale, lower opportunity cost, and then fully specializing. And so what this means is that history really matters. The direction of specialization with economies of scale depends on the starting point. So this can lead to some interesting implications. In fact, there can actually be losses from trade when we have economies of scale. So what do we mean by this? If economies of scale, so say that we aren't dealing with identical economies anymore. We're dealing with economies that do actually have some underlying comparative advantage, a difference in technology like in the Ricardian model, or a difference in relative factor endowments like in the Heckscher-Ohlin model. Well, it's possible for the effect of economies of scale to override these other sources of comparative advantage and lead to specialization in the wrong direction. And so relative to autarky, there will still be gains from trade in this case, but they're not as large as they could be. And this is because economies of scale can make it difficult for countries to specialize towards their comparative advantage if they're entering established world markets. So this means that free trade could be worse relative to policy that encourages scale in potentially competitive industries. So to expand on this a little bit further, there's something called the infant industry argument. So let's look at an example of this. So suppose that there's two countries that can produce watches, Switzerland and Thailand. But we're starting at a point where Switzerland is supplying the entire world market. And so this is their average cost curve, and this is the world demand curve. So Switzerland is producing at 0.1 here. And they can sell at a price of P1, which is equal to their average cost. So Thailand actually does have, in this case, an absolute advantage in producing watches. So at any point, at any given quantity level, Thailand always has a lower average cost of producing watches. However, we're starting from a point where Thailand is not producing any watches and Switzerland is supplying the whole world. And so what that means is that Thailand has to start over here at C0. And since C0 is greater than P1, it's very difficult for Thailand to overcome that initial disadvantage. And so it's unlikely that even though Thailand could be the low-cost supplier of watches to the world, that they ever will be without any further intervention. However, if Thailand protected their watch industry, so they engaged in some protectionist policy, import restrictions, for example, and they supplied their domestic market, that would put them over here at point 2. So now they're further along their average cost curve to the point where they can actually supply watches at P2. Now, since P2 is lower than P1, if we open up to trade at this point, Thailand would become the low-cost producer of watches to the world. Production would shift out here. The world would have more watches overall and at a lower price. So this can be an argument for protecting infant industries. Protection is not necessarily the only option here. More generally, there's something called industrial policy, and these are policies that encourage the growth of specific sectors through protection, or through subsidies, or through direct investment. So rather than protection and Thailand just supplying their own domestic watch market, the government could subsidize domestic production of watches to kick them off on their economies of scale, put them somewhere out here on their average cost curve, or they could directly invest. So the government could start a watch factory themselves, and that would start off the process of economies of scale. So to conclude, when we have economies of scale, we have falling marginal and average costs as we produce more. And with increasing returns, this means that specialization itself is a source of comparative advantage. So unlike the Ricardian or Heckscher-Ohlin model, there can be gains from trade for identical countries. Countries trade even though they're the same. However, analyzing the trade equilibrium with economies of scale can be difficult. The direction of specialization can be indeterminate as it depends on initial production. So history really matters. The state of the world as we open up to trade is actually going to play a very important role in determining the pattern of specialization in trade. And this provides a motivation for industrial policy to overcome counterproductive patterns of specialization.